Hi everyone. In today's lesson, we're going to talk about analyzing the graph of f prime. So in all the examples that you see here, I'm giving you the graph of f prime and I'm asking you information about f. So critical values occur when what? Well, we know the word critical value is used where when the derivative is equal to zero. So when f prime of x is equal to zero. So since this is my derivative graph, well, where is the derivative equal to zero? It's at these four spots. So at -7, -1, 4, and 8. So if you were to answer the question, the critical values occur when the graph crosses the x-axis. So if you wanted to write that down, you would just say it would be when f prime of x crosses the x-axis. And in this case, those values are -7, -1, 4, and 8. Okay? So next, what can we get from the derivative and how can we use it to find information about f? So we know that f of x, or the original function, is increasing when our derivative is positive. So when f prime of x is greater than 0, right? Remember when we did the number line and we would put pluses and minuses on the first derivative? That would tell us when f of x is increasing. And when the derivative is less than 0 or negative is when we would decrease. So what does that mean in relationship to this graph? Well, when f prime is greater than 0, what that means is where are all the y values greater than 0? So in other words, we're thinking above the x-axis. And when f of x is decreasing is when we are below the x-axis, right? So if you think about it, where are the y values greater than 0? Well, that's above the x-axis. Where are the y values less than 0? That's when they're below the x-axis. So if we talk about increasing, I'll use green to highlight increasing. Increasing will be from -7, this x value of -7, to -1. Then it's also going to increase from 4 to 8. So how we would write that is using an open interval. So it's going to increase from -7 to -1 union 4 to 8. That's when it's above the x-axis. So this is where f of x would be increasing. Then I'm going to use red to show where it's decreasing, which is below the x-axis. So it's going to be decreasing here, and here, and here. Now we're assuming these are arrows and they're going on forever. So this first interval is from -infinity on the x to -7, then from -1 to 4, and then from 8 to infinity. So if we put that in writing, it would be -infinity to -7, union -1 to 4, and union 8 to infinity. Okay, so when did we have a maximum and when did we have a minimum? So I want you to consider an f prime number line. Now, you don't have to write this down, but you can just, look at it to see where I'm getting the information from. So say I asked you to do an f prime number line and I had critical values here and here, and say this was minus, plus, and then minus. And I said, okay, what's happening with the original graph? Well, you'd say I'm going down from here to here, up from here to here, and then down from here to here. So a minimum occurred when I went from an interval of decrease to increase. And then we had a maximum value when I went from an interval of increase to decrease. And if we talk about increasing and decreasing, it's when I'm above or below the x-axis. So whenever I'm having a change from above to below is when I'm going to have an increase or a decrease. So from decrease to increase, it's a minimum. from increase to decrease, it's a maximum. So let's look at this value right here. At -7, we are going from below the x-axis, so this is your decrease, to above your x-axis, from here to here, which was my increase. So I've changed from decrease to increase, therefore this one is my minimum. And now if we look over here at -1, we're going from an increase to now below the x-axis, which is a decrease. So from an increase to a decrease, we have a maximum. So there will be, here is my maximum. And then this last, well, not last, but the second to last one, we went from here to here. So from below to above, decrease to increase, it's a minimum. So we have a minimum. And then the last one would just be another maximum because I'm going from above to below. So in other words, we have a maximum when the curve, when f prime of x goes from increase to decrease, or above to below. And then f of x is going to have a minimum when f prime goes from decreasing to increasing, or in other words, below the x-axis to above. So usually these questions are like, what are the x values of the increase of the minimum or maximum? There's really no way for you to find the y value without knowing the original function. So we have a minimum at -7 and 4. So -7 and 4. And we have a maximum at -1 and 8. All right, let's move on to concavity. So points of inflection and concavity. So we know that a point of inflection occurs when my second derivative, or f double prime, is equal to 0. So how does that relate to f prime? Well, if I'm taking the derivative of a derivative, remember that derivative is slope. So we're really looking for the slope of the tangent line to be equal to 0. So here would be a horizontal tangent right here. Here would be at a horizontal tangent. Here would be at a horizontal tangent. So these x values here is -3, +2, and +6. So your second derivative will be equal to 0 at those points, okay, where the slope of the tangent line is equal to 0, or in other words, it could be where f prime of x has a max or a min, right? Don't these values have a max or a min here, right? Those are maxes and mins at x equals -3, -2, and +6. Okay, so now the last part is concave up and concave down. So we know a graph is concave up when my second derivative is greater than 0 or positive, and we know my graph is concave down when my second derivative is less than 0. So that would be a normal number line. But remember, when I'm talking about the second derivative and I'm giving you the first derivative, it's all about the slope. So where is the slope of f prime positive, right? And then for concave down, we're looking for the slope of f prime to be negative. And that will give us our concave up and concave down. So if I use the highlighter, here is a positive slope where I'm increasing. Here's another positive slope. Those are my increasing. So if we write the intervals, it would be from negative infinity to this x value here, which is -3, union, this x value is 2, and this x value is 6. So union 2 to 6. That is where the graph is positive slope, therefore, is where it's concave up. Concave down will be where the slope is negative. So here to here is where my slope is negative, and from here to here, my slope is negative. So therefore, there we could write it as -3 to 2, union 6 to infinity. So this is a positive slope, and the yellows are negative slopes. And that will tell us about concavity. All right, that's it for today. Please make sure you have taken down all proper notes, and don't worry if this was a little confusing. We'll definitely go over it in class again tomorrow. All right, have a good night.